Hello everyone, welcome to my channel Learn Physics with Mamta. I hope you all are doing well. So today in my class we will learn the formation of image by a concave mirror. So let's start our class. So as you can see, I took a concave mirror. Okay. So whatever I said that we are going to discuss the formation of image by a concave mirror. So what could be the cases or the positions are, you see, pole, focus, center of curvature, these three positions, in between P and F 4, in between F and C 5, and beyond C. Total 6 cases will be there. So when you place the object at these 6 places, which type of image you will get, what type of image you will get, we are going to discuss in our class. So as you can see, first I took an object which is placed at the far distance or at infinite distance. For example, sun rays. Sun rays are coming from a far distance, right? Of course, we know the distance, but in numericals, we cannot take a large value or a big value. So that's why we'll consider this distance as infinite distance, okay? Because the sun is at far distance. So from the sun, few rays are falling on the concave mirror, okay? So I took only 2 rays. Of course, you can take n number of rays or many rays, but to form the image, at least 2 minimum rays we need. Minimum 2 rays we require to form the image. So I took 2 rays for the better understanding. If you take more number of rays, of course you will get a sharp image, but it will be clumsy. So I took 2 rays which are coming from the far distance. Okay. Now one question will arise. Why these 2 rays which are coming from the far distance are parallel? It can be oblique, right? I took parallel. Why? The answer is here. So assume that these rays are coming from the sun. Okay. You know that sun will be having a billion or trillions of rays, right? So I took few rays. Okay, here. Now if you observe the rays which are closer to the sun, okay, you consider this part, this part, this part. I think you all can see this part, right? I took. So if you observe the rays which are very closer to the sun, okay, this bunch of rays appears to be parallel. Yes. So can I say that the rays which are coming from the sun are parallel? Yes. If you go closer to the sun, or if you observe the rays which are closer to the sun are parallel. So of course oblique also, but why I took parallel? Because this is the reason, okay? The rays which are coming from the far distance, I can consider it as parallel. So I took 2 parallel rays, okay? So here, like in our first class, we discussed the ray rules, right? So here we are going to use the ray rules and we are going to discuss the formation of image, okay? So now you all can see the concave mirror, and here pole, which is the midpoint of the mirror, focus where all the rays which are parallel to the principal axis meet. That point is focus, and this is the center of the curvature, which is the center of the imaginary sphere. So here you have to remember one thing. Whatever the distance you are taking in between pole to focus, that must be equal to focus to center of curvature. So for example, pole to focus you are taking 10 centimeter distance. So focus to center of curvature will also be 10 centimeter distance. Then only you will get the exact position of the image. Otherwise you won't. Even this condition satisfies in the ray diagrams of lens also. That will discuss in the upcoming videos. Now we took the 2 parallel rays, right? They meet at a focus, right? So we got the image. So as these 2 reflected rays are meeting, that's why that is a real image. And I told you that real image is always inverted. How? We are observing, right? We can able to see all the objects nearby us, whatever, pen, board, whatever. So is it real? All these objects are real? Yes. We are observing it. These all objects are real. Okay. As you know that in 5th class we have already learned it. So our eyes consist of a lens. So whenever we observe any object, that light will falls on the object and it will reflects back to our eyes, which means it passes through the lens. Then that image will forms on the retina. Okay, like retina acts like a screen in our eye, so that image will be inverted, as we have learnt that. So whatever like our eye observed the object, or whatever the like retina got the image, that image or the message will be passed by the nerves to the brain. While it is passing to the brain, which means the message which is passed by the nerves to the brain will be erected. So I told you, right, whatever we are observing, that image will forms on the retina as inverted. Everything will be looks like upright, but while the message is passing through the nerve to the brain, it will again reversed, which that's why we are able to see the objects upright, which means not not upright, erected. Okay, so the image is real. Real is always inverted. Okay, where we have placed the object at infinite distance. So while drawing the ray diagrams, you have to write the characteristics of the image also by seeing the diagram. So first you have to write about the object, where you have placed the object. You have placed the object at infinite distance. Okay, image forms at focus. Okay, next you can see what is the size of the image compared to object. It is point sized, so that's why the image size is point sized image, or you can write diminished image. Diminished means smaller image. Okay, this is a very important question, 6-mark question it is. Next, here m is less than 1. Magnification, m means magnification. Like in our upcoming videos, I'm going to explain the magnification in depth. For now I'll explain you in a short form. Magnification is nothing but we are defining the size of the image with respect to the object. We have written here point sized image, right? So point sized means diminished. So we will write m is less than 1. Less than 1 means smaller size, greater than 1 means enlarged, equal to 1 means same size. Okay, so these are the characteristics you have to write after drawing. Okay, which means radar. Now coming to the second case, in first case we have placed the object at infinite distance. Actually our aim is we are going to move the object slowly towards the concave mirror. It was at infinite distance in the first case. Now we brought the object beyond the center of curvature. So in physics we will denote the object like this, one vertical line with the arrow mark. This is the top and this is the bottom. So I am denoting it as O, which is nothing but object. Okay. Now as I told you already in the first case, to form the image we require 2 rays. Okay, minimum 2 rays. In the first case the object was at infinite distance, we took parallel rays, but here in this condition it won't be possible. From the head we have to take 2 rays. So one I took parallel. Okay, 2 rays at a time parallel to each other we can't. So I took one parallel ray and I took one ray which is passing through the center of curvature. It's your wish. You can take one more ray which is passing through the focus or passing through the pole. I took it which is passing through the center of curvature. I'll tell you why. Okay. First you can see the ray which is parallel to the principal axis. According to the ray rule, it must passes through the focus. So after reflection it is passing through the focus. Next, the ray which is passing through the center of curvature, we know that it will retrace us back to the same path. That's why I took the ray which is passing through the center of curvature. No need to draw extra ray, right? Only single line, because light will reflect back. So I took the ray passing through the center of curvature. Now you see this line is passing through the center of curvature. This is incident ray, this is reflected ray. Arrow marks are very important. If you miss the arrow marks, so 2 marks will be deducted in the examination. Now you see here, this is the reflected ray and this is the reflected ray. These 2 reflected rays are meeting at this point. This is called point of intersection. So if 2 reflected rays meet, what I told you, that it forms a real image. So this is the image. What you have to do is, so at this point you have to draw one vertical line, then you have to draw one arrow mark which must be upright. upside down. So this is the image. Now you observe like where we have placed the object beyond center of curvature. Where do the image will forms? In between F and C the image will forms. Okay. Is it real? Yes. Because two reflected rays are meeting, which means it's a real. If it is a real, that will be inverted. Now you have seen, right? So this is inverted image. This is a rectangle object. This is inverted image. Now you compare the size of the object and image. Object size is bigger than the image size. So image size is diminished. See, whenever you are writing the characteristics, you are writing the characteristics of image, not the object. So image size is diminished, means smaller compared to the object size. Okay. Now here many students will get the confusion that we are writing, right, image forms in between F and C. They'll think that the image will exactly form in between F and C. For example, for me, the image forms in between F and C, but not exactly at the center. Okay. See, image can be formed in between C and F anywhere. At this position, at this position, at this position. But it should form in between F and C. Wherever you will get the image, but it should be in between F and C. Okay. Now coming to the third case, I placed the object at center of curvature. As you can see, O is nothing but the object. Okay. So as we know that we require at least 2 rays to form the image. Okay, so I took one ray which is parallel to the principal axis. This is common in every cases. We'll take parallel ray. Okay, next one more ray which is passing through the focus. Like in previous case, we consider ray which is passing through the center of curvature. Now it is not possible because the object is at center of curvature itself. So like from the top we took 2 rays. The ray which is passing parallel to the principal axis, it meets at focus, okay, after reflection. Next, the ray which is passing through the focus, it travels parallel to the principal axis after reflection. Now you see, these 2 rays are the reflected rays, okay. This is the reflected ray of first ray and this is the reflected ray of second ray. These 2 are meeting at this point. They are meeting, that's why that's a real image. And you can see at this point of intersection, you have to draw one vertical line. Okay. And you have to draw the arrow mark at that particular point of intersection. So you can see the image is forming. So that's why that is real. And you can see it is inverted. So first what you have to write the characteristic. The object is placed at center of curvature. Where do we got the image? At center of curvature. You have to write like this. Real, inverted. Now what is the size of the image? You can observe at the size of the object and image are equal. That's why we will write image size is equal or same size. Okay. And also you can include magnification, which is nothing but size. M is equal to 1. I told you equal size or same size is nothing but equal to 1. Magnification equal to 1. So now in the fourth case, you can see that the object is in between focus and center of curvature. See, already 3 cases completed, like the object is placed at infinity, then beyond the center of curvature, at C completed, now in between F and C. Now, this is the object, okay. From the top, I considered 2 rays. As like in 3 cases as we considered, here also we considered 2 rays. One is parallel to the principal axis and one ray is passing through the focus. Okay, the ray which passes parallel to the principal axis, okay, it passes through the focus after reflection. Okay, next coming to the second ray, this ray is passing through the focus. So after reflection, it travels, okay, parallel to the principal axis. Now you can see these 2 reflected rays are meeting at this point. So at this point, you have to draw one vertical line and you have to give the arrow mark at that particular point of intersection. Okay. Now you can see this is the object and this is the image. Now where we have placed the object is at, in between focus and center of curvature. Where do we got the image? Image forms beyond center of curvature, beyond the center of curvature. See, if you remember in the second case, when we placed the object beyond the center of curvature, we got the image in between F and C. So it will be reversed. If you place the object in between C and F, so you will get the image beyond C. Reverse to the second case. Okay. So now if you observe, we got the we have the object, we got the image. How is that image? Real. Okay. As we can see, the image is forming by intersection of two reflected rays. Real is always inverted. Okay. Next, what is the size of the image compared to object? It is this time is bigger or else enlarged. So the size of the image is enlarged, or else you can write magnified or bigger. And M is greater than 1 because the size is enlarged. Size is bigger, that's why M is greater than 1. Yeah, so this is the fifth case where we have placed the object at focus. Okay, I took two rays from the top of the object. Okay, so one is parallel to the principal axis and one is the ray which is passing through the pole. Okay, now you see, we know that the ray which is passing parallel to the principal axis, after reflection it passes through the focus. Okay, this one. Now coming to this ray, okay, which is passing through the pole. I don't have any other chance, but I can take a ray which is passing through the center of curvature, but you won't be able to understand. So I took the ray passing through the pole. Now if I draw the tangent here, okay, this principal axis will act like a normal. Okay, so according to the laws of reflection, first law says that angle I must be equal to angle R. Okay, so here whatever the incident ray you are taking, the angle between this normal and incident ray must be equal to this angle between reflected ray and normal. So I took the ray. So this is the incident ray, this is the reflected ray. So now you see here, these two rays appears to pass parallel to each other. So now my question is, will these parallel rays meet? Like in mathematics, we'll say that two parallel lines will not intersect, right? But in physics, we have to think logically and practically. So in the first case, I took one example of sun, right? So the rays are coming from the infinite distance, right? We have considering it as parallel ray. I can consider the oblique rays also, but I considered parallel rays. So if you consider the rays which are closer to the sun, it appears parallel, right? So in previous case, whatever the four cases we have seen, we got the image, right? Which means parallel rays can also meet, right? So that's why we can say that these two parallel rays also can meet. So that's why we are saying that object is placed at focus. Okay, image will forms at infinite distance. We don't know, but they will. So if we consider that those two rays will meet at some infinite distance, so we'll get the real and inverted image. But coming to the characteristics, whether the object will be enlarged, of course, if we think that object will meet at infinite position or distance, image will be enlarged, but we cannot write. So according to the state syllabus, we should not write the characteristics. Okay. This is the sixth case, which is the last case where we are placing the object in between pole and focus. So this is the object where I took two rays from the top of the object. One is parallel and one is passing through the pole. Okay. The ray which is passing parallel to the principal axis, after reflection, it passes through the focus. Next, I told you that if you are taking the ray which is passing through the pole, the angle I must be equal to angle R. Okay. So if you measure these two angles, it must be equal. Now if you observe, are we getting any image? No. See, these two reflected rays are appears to diverge. Diverging rays will never meet. Okay, so we won't get the image. Now what we are going to do is we are going to extend back the reflected rays. Okay, and this is the another reflected ray. I'm going to extend back these two rays. So here you see, here these two extended reflected rays are meeting. Actual reflected rays are not meeting. The extended reflected rays are meeting. So at that point of intersection, you have to draw one vertical line as we are doing from the last 5 cases. At this point we have to draw the arrow mark. Okay. Now this is the object and this is the image. I already told you that if actual reflected rays will meet, we will get the real image. If extended reflected rays will meet, then we will get virtual image. So now this is the virtual image. Virtual image is always erect. This time the image is not inverted. Inverted, when do we say? If the image will forms below the principal axis, that will be inverted. Now this time image forms above the principal axis. So that is virtual and erect. So the image is virtual erect. Object is placed between P and F. Okay. And image, where do we got the image? Beyond the mirror. Okay. Beyond the mirror. Next, what is the size of the image? It is enlarged compared to the object. And the magnification is greater than 1. This is the case like we'll use in our day-to-day life. Our dentist or ENT specialist use the concave mirror. This is the case, 6 case where they will observe the image of the teeth by using the concave mirror. If they will observe the image as in inverted, what is the use of it? So hope you all have understood these ray diagrams. So if you are having any doubts, you can comment down.